All right, let's see. Testing, testing, one, two, three. Seems like we're good. I think the live stream is going. Okay, let's get ready for this. All right, we should be rolling. Everything seems good with this. So let me know, those of you who are tuning in, if the audio sounds good. I can adjust everything from where I am right now. So if something's not quite right, I can fix that. But yeah, this will likely be a several hour stream if all goes well, and I have the time to do it. We have quite a while for these storms to continue going. So yeah, I'm going to show you the outlook first. This is some of the ground truth type of stuff that we are seeing. We have this is I'm pretty sure. Well, we have one coming in the next like hour or so. I think it's issued at 3, so I think it's gonna drop like in like 15 minutes. I'm gonna actually look this up on the fly. Let's see. SPC Outlook. Let's see. Let's see when the next one is supposed to be issued by 20ZC. Yeah, we have 15 minutes until this is going to drop. So let's see. This is the current one. I don't like to use this way to look at it. This is a little bit better because I can zoom in. But yeah, like Newton over to Bloomington is the area I'm most concerned about with this. Currently, the radar looks like this. We do have a cluster of storms ongoing, like just south of Louisville. I am somewhat concerned about this area just south of Louisville. Initially here, I'm gonna click on this and we'll just look at the actual radar. So some of these have that look. This one right here, for example, already appears to be rotating. Let me see. It is absolutely rotating. So if you are south of Beachland, and this is just actually just over the border and technically into Kentucky here, Andyville area, you definitely need to be watching all of these storms. I'm going to take a broader look first. All of these storms in this area, this other cluster up here needs to be watched closely because again, our outlook looks like this. So these are not even in the main area. Uh, we got some time before we really get going with this. So thank you guys for tuning in. I see your comments. I'm going to read these in a second. But yeah, so let's see here. We're also a big thing for an event like this is going to be, especially in the beginning parts of it, like this, is going to be watching uh, the satellite because any areas that start clearing will have the most potential for more convection to develop. I can turn on CAPE levels with this and then turn off the actual data. So what you're looking at here is the amount of instability the atmosphere has throughout it. So this kind of area right here has the most, of course, and I mean we can. In fact, I'm going to do this now. I'm probably going to leave it on as well. I'll turn on our day one outlook. So you can see the most of it is right over the area. So yeah, this is definitely something we need to watch. The instability is developing. We can turn on the jet stream as well. I know this is probably messy on your screen, but at the same time, we can see that the instability and wind shear are overlapping right over this area. That's why they've issued this. I think they've actually kind of nailed this on the head when it comes to where it is and what the outlook is issued for. I'll do it in this one. So I'll break this down for you and tell you what these risks are specifically for. So we have a 10% risk of a tornado within 25 miles of any given location in this yellow region you see here. And these black lines kind of dash through it mean that it has potential to be the tornadoes have potential to be much stronger than normal. EF2 plus tornadoes are what they're calling for here. So I'm going to click on this. You guys can pause this and read it. There's a lot here. Not all of it is as important, but at the same time, you can read that if you'd like. We do have storm chasers on the ground. That's what these circles are. They're different storm chasers, and you can click here and see their current perspective. So Yeah, we have a few, and they're all on. What is this? I think this is Interstate 50. Yeah. So they're heading east on Interstate 50 over probably to head towards Bloomington area. I don't think they're going to get on these storms down here south of Louisville. I just don't see them aiming for these, but they are. Some of them are already rotating. So that being said, I'm going to read you guys' comments so far. There's quite a lot of them. So let me see here. Um, yeah, clean up my chart. Okay. So yeah, the significant tornadoes are defined as EF2 or greater tornadoes. I think it's EF2. It could be EF3 tornadoes. Severe thunderstorms, few tornadoes. Yeah, I don't know. I don't know. I need to look that up and see what it is. I'm pretty sure it's EF2. Yeah, hatched area probability of EF2 to EF5 tornadoes within 25 miles of a given point. So if you take that information and then overlay it here, that would mean that if you're in say Bloomington, Indiana here, you could draw a radius of 25 miles around that location, and there's a 10% chance that an EF2 or greater tornado touches down. That's a pretty significant threat. I mean, there's obviously a lot of people. In fact, it'll tell me the total number in the significant severe area. We have 1.2 million people under the gun in this yellow shaded area. Obviously, this green that extends out is even larger. So uh, that is definitely something of greatest concern over the next couple of hours. I mean, obviously, you can see that area right there is mostly clear right now. That's actually not a good thing. You can see it on satellite as well. It isn't good because it will lead to more instability developing the longer the sun stays out. So definitely need to watch that. Let's see here. I'm gonna reload this. So this is one of the latest runs of uh, the RRFSA model, one of our pretty good short range models, just to kind of go over for general severe potential here. So we're going to look at it here. I don't know if the latest one has run yet. Let's see. It is running. And we have, it looks like enough frames of it. Let's get everything framed. So this should work. Let's start this off here. So it's initializing pretty well. We got a few clusters of storms in different locations. Let's start this off here. So this is what concerns me most. These storms right here in this area, I'm going to pinch zoom right here. They have these little black streaks coming off of them. That indicates the potential that these storms will be rotating. And if you're watching this and you manage to be under one of these, that doesn't mean that you're going to see a tornado necessarily, but it's this model's idea of where the most rotation will be and in what storms. So we can move this on a few more hours here, and those storms look intense. They last a while. So this would lead me to believe we have long track tornado potential. So this product here, let's pull this out to the end. This is very concerning. I will say that the RRFSA model has an overconvection bias. It tends to put more storms, put more information in general on your screen than there actually might be. But even regardless of that, what you're looking at here is updraft helicity swaths. So it's where the model is showing the most potential for rotating thunderstorms. You want to look here at the value and the amount of these things. Do you see how long some of them are? This is like hundreds of miles long. So if this what this really means is that we have potential here for these storms to be long tracked, and long duration tornadoes could definitely be a possibility. So I'm going to let this load in, and I'm going to take a second to read your comments. So let's see, 50 pounds per person. So the entire area that is yellow on this map, let's pull it back up here. The entire area that's yellow on this map is that 10% risk. There is probably locally higher areas in there. Um, I mean, some of these comments, it's ridiculous. I know you guys are joking. That's the funny thing. It's kind of funny. I'm just gonna treat it as if you guys are being completely serious because this is actually kind of funny. I'm not gonna lie. But yeah, I mean this. If you have a genuine question, you might as well ask it because I might be able to answer it. But uh, but yeah. Anyway, I don't expect to see a whole lot happen over the next little bit of time. We need to very closely watch this cluster of storms right here. Let me reload this. So right here, we can pull the radar up. Obviously, you see this cluster down here in Kentucky, kind of getting up into southern Indiana, but this cluster over here is not doing a whole lot right now, obviously. They look smaller, they don't have any warnings on them, all that good stuff. But regardless, um, yeah, that we need to watch that cluster closely because based on some of our model guidance, it was what showed up the most when it comes to the rotation and all that good stuff. So this right here, let me get everything within frame because I can't even see what time this is supposed to be at. So this is starting off now. This is one of the reasons that we have such an intense area of storms right now, is because this jet stream over this area is so strong. I'm going to show you the observed jet stream first, and then I'll go into the model version of it. This is what we're actually seeing. This is what the weather balloons picked up and aircraft and all that stuff. It stitches together to make something like this. So it might be a little bit hard for you guys to see what states you're looking at, but this right here is the area that was seeing the most storm activity right now, just kind of along and south of the Ohio River near Louisville, Kentucky. So you can see that the bulk of this jet stream is actually down here. That's where the jet streak is. That's where it is. And so the fact that our risk area up here is to the north of it is interesting to me. Typically, you would want this to be oriented where it kind of overspreads the entire region. Uh, but regardless, what this is also telling me is that we're in the left exit region. So that is one of the two favorable regions. Say it right. One of the two favorable regions in a jet streak for the most intense convection, and it is positioned right over our area here. So that is somewhat concerning. So this model, this is not an upper air biased model. It's not the greatest thing to look at. However, it will give us somewhat of an idea. As we get towards sundown, this is about 7 p.m. Central Time or so. We see it's still this very broad, maybe slightly weaker jet stream. It's kind of overspreading the region. This is one of the reasons I think that yes, we'll see some stuff go on right now. It's absolutely possible, but as we get closer to sundown, we probably will see this start to increase a bit. Intensity and coverage of these storms, particularly in the risk area. Because you notice how all these storms are down here. Now, I do want to say something, and that is this brown area is not just it's not a nothing threat. If the entire area was brown, which it was not that long ago before they issued this a yellow, that is still a very much notable risk. So these storms down here absolutely have the potential to be dangerous. So I'm gonna read your comment again. Let's see. Is Dollywood okay? They're cooked. Let's see. Where are they at? Somewhere in here. I mean, where are they? That's yeah, they're somewhere in here. They'll be all right. The risk area for tomorrow. Let's turn this back here. So just a overall thunderstorms threat. Uh, let's see. Yeah, it's funny. I'm not gonna lie. Let's see here. Yeah, they're fine. Dollywood is fine. I wouldn't worry too much about them. They'll be all right. If you could let me know why you care, that's my question. Because I know who you are. I know where you live. Um, I want to know why you care so much. But so for those of you who are tuning in, and I can see because I've got analytics pulled up on one of my computers here. There's only two of you watching, and I know who you guys are. So it's kind of funny watching this. But regardless, we do finally have a severe thunderstorm warning over areas of where the states are a little bit hard to see. Where is this at? Bloomfield, Kentucky. I hadn't even heard of that. Fairfield. So let's analyze this a little bit more. This looks like a hail producer to me. This does not look tornadic, really, in the slightest. Let's see. Um, yeah, there's definitely some hail mixed in with this. It's not huge when it comes to hail yet, but areas you see in these black pixels right here definitely have the they could be associated with the stronger hail and bigger hail. We'll watch and see if reports come out later. In fact, while I'm thinking about it and not a whole lot's going on, um, let's spell this right. I'm gonna go ahead and pull up the SPC storm reports page. Uh, and we're gonna see. This is for the 19th. So none have come in yet. A few hail and wind reports have come in. So, for example, where is this map? Um, this might be it. I think this is it. So yeah, this is our essentially live reports interface. So yeah, there have been some hail reports with this. It wouldn't lead me to believe a storm like this is all that capable of doing anything crazy. But regardless, did you just see Nazareth on what map? This map? It's possible you did. I can look back at it. But who knows what you saw? Oh yeah, Nazareth down here. So yeah, Nazareth is just to the south of this morning. It should be okay. Although they're not out of the woods yet. There's other stuff to watch in this area. But we do have this severe warning in this area. I could name these little locations for a while. And so one thing I do want to mention is that they've just upgraded this to observed. So if you look at the source, public reported quarter size hail in Deatsville, looks like how you pronounce that. So that would lead me to believe that this isn't just a radar indicated thing. Where's the actual tower if I use the radar? So yeah, the tower is reasonably far away. So you need reports. It's very important to get reports for this because the radar can get things wrong. And what I mean by getting it wrong is if the radar's over here and it sends a beam out, the beam is going to be higher up in the atmosphere because the Earth curves. So it's important that we get reports and these observed type of warnings because of that, and etc. So let me take another minute here to look over your comments. I did not see this warning either. Yeah, let me take a minute to look over your comments. Acknowledge your response. You asked why. Cared about Dollywood? Why did you care about Dollywood? Um. Oh, so I know you guys. So yeah, Luli, Walker, Rollins. Let's see here. Yeah, I see it. I see it. Um, I did not know Rollins was going to Dollywood. I did not know that. Let's see. Yes, you did. You did see Nazareth. Let's see. Where's Eden at in this? She didn't say anything. Yeah, she's not said anything. Prove me wrong. Uh, anyway, so yeah, for those of you tuning in right now, we are continuing to see warnings issued across some of these areas of particularly Kentucky. As of right now, we will start to see this spread north with time. So this is what we're seeing as of right now. This is all the warnings that we're seeing. Um, so yeah, this is what we're seeing right now. We got a few severe warnings. One for observed hail. One for So both of these warnings, these kind of orange boxes you see on your screen, they're both hail related. The wind in these is nothing specific. It's not observed wind. There has been observed hail in these though. So something to watch there. Let me reload this again. Satellite kind of looks like this. So I do just really want to, in fact, I think I can zoom in here. So we'll use this one. So just north of our risk area, along and north of our risk area, there is just clearing going on. You can see the ground through the clouds, which means the sun can too. And if you have clearing going on, you do want to make sure that you're careful about getting storms fired, because if they fire in an environment like this, they're dealing with quite a lot of instability. In fact, I'm going to turn this off. So you can see our risk area. I've got to move this to the south. It's bothering me. So turn this off, turn this on. So just south of our risk area here, this is where we need to focus the most right now. We've got 1,200, maybe 1,500 joules per kilogram of mixed layer CAPE. That's somewhat concerning to me, especially in an environment like this where you don't need this kind of rocket fuel type of instability. This product right here will show us instability. It's a lot more conservative at 500 joules per kilogram as opposed to 1,500 joules per kilogram. If we turn this to surface based, this is that number. So we have more instability if the parcel rises from the surface. That's important. These air parcels, where they originate is going to be an important factor in determining the instability. So I'm going to do one thing, and that is switch models, go to the latest run, and where are we at here? I'm going to pick different product first. This one should be fine. So latest HRRR is coming in interesting to me. Let's start off. It is now 3 o'clock, so we should check for the new outlook. But, and say this area right here. So it's important that we figure out where the parcel originates. If we have a parcel that originates at the surface, this white line is the parcel path here. If it were to originate at the surface, it would have the most potential for instability. You can see, if you look down here, I'm going to pinch zoom this. Surface is SFC. There is 1,100 joules per kilogram. The mixed layer CAPE is about half that. So the reason you look at mixed layer CAPE is because if this parcel, this is going to be a bad line, I promise you. If it originates here and then kind of goes up like that, there's a lot less instability to work with. And if you've never seen this map before, there's a good chance you haven't. Let me kind of explain what you're looking at first. So over here on the left, let me pinch zoom everything, get it in frame. So on the left here, you have a green, red, and this color can change. It's white on this one. It can be yellow. It can be several different color. But what you're looking at here, green is dew point. That's just the moisture level of the atmosphere. The red is the temperature, and this white is the parcel path. All of your temperature lines are oriented like this. You can can't see them kind of dotted in the background, so they're skewed. Normally, you would think about a graph like this: temperature decreases to the left, increases to the right. You would think about it like that. It really increases like this, decreases like this. So if you see this white line to the right of the red, that means it is warmer. It's more buoyant. And your preschool level knowledge would tell you that warm air rises, cool air falls. It sinks in the atmosphere, especially relative to other warmer air. So any areas where this white is to the right of that red line is where we have instability, and we have a decent amount of it. The further they are apart, the more instability we have. So if you originate this line at the surface like it is right here, it starts all the way down here at the surface, 0 kilometers, and it works its way up. If you start it down here, it reaches saturation first, and then follows the moist adiabat up into the atmosphere. If it were to start, say, up here, we get a parcel that originates here. It has far less instability, significant. It's about half, which is why the mixed layer CAPE is literally right about half of the surface layer CAPE. So it's important we figure out what layer to observe here. It's very hard to tell. The better estimation to use is to use mixed layer CAPE. So if you do use mixed layer CAPE, we have a lot less. 500 joules per kilogram is a widespread number, maybe locally higher amounts, but nothing too crazy. So yeah, that's a little explanation for that. So let's check back in here on all the storms. Let's Let's do this here. Probably gonna have to reload this, actually. So let's see, let everything load in. So we have the same warnings as they upgraded this. Oh, they've increased. So even though this says quarter size hail, the maximum hail size is larger than quarter. So that's interesting. Typically they don't do that. So I'm going to reload this as well, because these reports are going to be a very key piece of information in this setup. Yeah, we don't have any other reports as of right now. So I'll have to watch that for changes. I mean, these storms like this one, this flashing warning, it just stopped flashing. This is a new one, and I'm gonna have to turn on. Let's turn this on, turn that off. So it's annoying how we have to do this, but we do. So here we go. So it's hard to tell what states you're in when you're so zoomed in, man. It's bothering me. Central areas of Kentucky are the target area for the next little bit of time. Just a little bit. I mean, nothing crazy, but we will have to watch these. There's kind of several storms. Any of these could go warned at any given time. And I do want to watch these storms. Like, let's take this one, for example. Let's analyze this one. This one's been warned the longest and has seemingly the strongest instability core in it. So anywhere you see in these black pixels right here, those are the areas where hail is most prominent in the storm. And we can look at a few different products. So this is correlation coefficient. Areas in blue like this is where the radar beam is going through the atmosphere and it sees something it's not used to seeing. So this red is all the same. Raindrops are mostly the same. Obviously, they can vary by size a little bit, but hail is obviously it's harder. It's not the same as just liquid water. So these areas, particularly in green right here, is where I'd want to watch for the most hail over the next little bit of time, especially because hail can kind of fall out of the atmosphere. You can see it, it goes up in the atmosphere, kind of transports over, and then falls back down. So, yeah, let's see. There's the latest with that. Is it rotating? Let's click on this. Is it rotating? Not really. In fact, not at all. It's not really rotating at all. So just some hail producers. I mean, that's really more than anything else. That's what we're gonna have to deal with for the next little bit of time. I said this before. We need to watch this area for the most potent of the severe weather. Obviously, all of these warnings and special weather statements are down here out of the main risk area. This is it right here. So along areas of I-70, Interstate 50, this is interesting to me. You see how all these storm chasers, like Brandon Kovic, he's a huge storm chaser. He's headed west right now. I would figure that they're heading east in a setup like this, but this also tells me they might be targeting this little band of storms because it's projected by models to be the most severe out of everything. So I'm going to reload this. This is the latest HRRR. This is a different model than I showed you just a few minutes ago, but this is one of our better ones. The RRFS-A model is not the best thing out there. It's okay, but it's not the best thing. So this is initializing at 3. It's 313 right now. So this little area of storms is being picked up pretty well, I would say. And so let's take this on a few more frames. It really doesn't get stuff going more until we get to like 7 p.m. Central Time, 6 p.m. Central, which is interesting to me, considering these storms are already somewhat intense. But I mean, it's this model's idea of it, and it's going to vary. I'm going to show you this because this is the latest full run of it. So it did something similar. It kind of got these storms going along the Indiana-Illinois border, and then they're most intense right there. There's another track of it. Let's look at the updraft trilogy tracks with this. So it's pretty similar to the RRFS-A model that we looked at a second ago. you see several, 1 to 2 of these pretty intense looking areas of rotation showing up. So definitely have the potential to see something. So I'm going to let this load back in here. And actually, you know what? I'm just going to put it on this and play the loop. So yeah, here we go. Now I'm reading your comments. So let's go over it here. We got some interesting comments. Let's see. Scroll through the comments. All right. So I don't know who's talking. For Luli here, I have no idea. Um, anybody's guess at this point. But yeah, this is interesting. What happens if you put the lime in the coconut? Um, I don't know. That's one thing I've never really been able to figure out and understand. I'm not gonna lie. So interesting. Yeah, I'm gonna let you guys go with that. I don't know what you guys are doing in the comment. If you are watching this, and you're looking at these comments and thinking this is absolutely ridiculous, these are my friends. So they're just trolling. They're not. Don't worry about them. Um, so yeah, if you are tuning in now, welcome. We're gonna probably be doing this the next couple of hours. I might get bored with it if nothing really happens. I don't expect that to be the case though. I do see this intensifying more as we get over the next couple hours. Let's turn this back on. I don't know why this keeps doing it to me. So let's see. What is weather? What is weather? Definition for weather. It's an interesting one. I don't really know. I don't really have any idea about how to define weather. Crazy that two of you have said that now. Weather is just energy in the atmosphere that we can see, that we can observe through our five senses. I guess. No? Okay. Let's see here. We're gonna go over these and see if they are rotating. What is going on here? So something seems to be wrong with my hotkeys, but because we're not on the local radar side, let's do it like this. So this storm here is somewhat bothersome because it has that hook shape to it. Uh, really, it kind of goes like that's the worst color I could have picked. Let's pick a different one. So it curves like this. This means that in this region of the storm right here, it is ingesting warm air. I'm going to try something. There's a different application I like to use when looking at radar. So I'm going to try it and I'm going to see, because I can see my stream right now. I'm going to see if it outputs and my computer can handle it. For whatever reason, my computer does not like it a whole lot. It's very weird why it does that. But I'm gonna try that. So let's go here and it's probably gonna have to open. So let's let it do that. Um, takes a minute. So let's see here. I mean, it's working as of the way it is right now. I'm gonna watch the output and see if it starts lagging or not. It seems fine. So let's see here. Yeah, it seems fine. I'm gonna use this if I can because I like it better for radar specifically. Um, let's see. Yeah, if you can hear my voice okay, then let me know. I do need to know how this is coming out on you guys' end because in the past this has not gone too well when it comes to live streaming or video recording. It does not do too well. So I'm going to use this for a few different reasons. It does warnings, I think, a little bit better. I like the way it does warnings, and it does storm tracks. I like that. Um, and we can change tilts and all that. It's just a little bit more intuitive. So, okay, thanks, Rollins. I appreciate it. So, yeah, this storm right here, Johnsonville, Kentucky, specifically, it is starting to rotate. It wasn't just a few minutes ago, and it is starting to. In fact, it appears almost to have two areas of rotation based off of just radar. The radar tower is off this way. Again, I'm picking the worst color. Feel free to make fun of me in the comments. This is absolutely ridiculous. The radar is off to the left. So a little bit of basic understanding here. Greens here, like that area, this little area, green on this map, this product, means that the pixels, those hydrometeors, are moving to the towards the radar tower. And then the red indicate they're moving away. So if you use some deduction here and you got these two areas, this is moving towards the radar, this is moving away. That means if you were to complete the circle, they're rotating. So this area is rotating, this area is rotating. For this storm specifically, we're going to have to watch and see which area it kind of becomes more dominant. This really, more than anything, to be completely honest, looks like a hail producer. So I wouldn't be too worried about this doing anything with tornadoes quite yet, but we will watch it because the environment is so supportive of this. That's just the kind of overarching thing with an event like this is that there is just kind of a perfect set of overlapping ingredients when it comes to this. Well, this storm needs to be watched closely, south of Johnsonville, Kentucky. What is this, Fairview? Yeah, so we need to watch that closely. Well, what about some of our other storms? Back up here towards Effingham, what state is this in? Illinois. This is another one we need to kind of watch because this cluster band feature of storms right here has the potential to really intensify as time goes on. So we'll need to watch that for sure. Now I'm going to click back down here. We're going to analyze this storm a bit further because I think it has the greatest potential to do something as of right now. So you guys are cooking me in the comments. I'm not going to lie. This is kind of funny. So we're going to analyze this storm a little bit on a deeper level here. So this is reflectivity. This is going to show where hail is, where the rain is. Particularly in these purples right here, this is where the most hail is in a storm like this. So you would then take this, you would look at velocity. This is what I just showed you it was. So there's a distinct area of rotation right here. Something that definitely needs to be watched. This right here is what we call differential phase, or ZDR. What is this stuff? Is this that, or is this a different one? ZDR. This is this is differential reflectivity. This is not ZDR. This is differential reflectivity. So areas right here in the middle, see where it's kind of gray? It's surrounded by more color. So you got color. Yeah, I'm picking the worst color. You can roast me for that because that's crazy. There's this area right here kind of surrounded by this thing right here of less color. That indicates that anywhere you see this pale like gray color, what that is hydrometeors, things that the radar beam is hitting that are almost perfectly circular. And so, raindrops are obviously kind of like they're smaller at the top. They kind of taper off at the top. And the radar knows that. We have the technology now to be able to observe that and see that. So when the values go down and they get closer to the same size in both planes, that means that they are circular. And when they're circular, that's what hailstones are. It's like the perfect circular balls. So that's why the radar picks up on them like that. Now, moving on through our products here, this is specific differential phase. Areas with the most color here, these kind of oranges, yellows, greens, that's where the updraft is the strongest, the updraft itself. So that's what this is showing. This is correlation coefficient. This is, like I mentioned a minute ago, this is where areas in red is what the radar sees very often. Most of the storm is rain. Areas in this green and blue is where hail could be. You would also see, this would mean that something odd in the atmosphere. You would see this on a debris ball with a tornado. Tornado's ongoing, you look for these areas of blue because obviously 2x4s are not meant to be in the sky, and the radar knows that. It sees something it's not used to seeing, so it comes up in blue. Next product in the list, this is vertically integrated liquid. So what this is showing is just the amount of liquid precipitation that is in the column of the atmosphere at a given time. So from the surface all the way up, that's what this is. And the higher values indicate more of it. This could indicate hail. This could indicate heavy rain. This could indicate snow in some instances. I would be watching this mostly for hail at this time. Now, this product right here, this is Ecotops. And what this really is the height of the anvil of these clouds. I'm going to click on a different site. Yeah. So with a different site, you can see the actual cloud top height. So right in the majority of this area, 30,000 feet or so is the max cloud top height. 30,000 feet. That's pretty high up there. That's still nothing crazy. Our scale goes much further than that. But yeah, we could definitely see these storms go higher than that. The atmosphere is not overly supportive for these really tall thunderstorms. So we'll have to watch, but the taller they get, the more hail potential they're going to have. So this is the latest reflectivity frame. Definitely starting to grow that kind of dog leg hook echo right here, where it's kind of pulling a precipitation around it as it's rotating. Velocity looks like this. This is ramping up. These areas of outbounds, these areas of reds are increasing. There's even a pixel here showing near 60 miles per hour. And these greens, so they're bordering each other. So let's take an overall broader look here. We even have severe weather outside of the risk area to begin with. So let's click on these. Yeah, these are just like kind of hail producers almost. This is one down here. So where's the tower? Yeah, this is rotating as well. What state is this in? Kind of in areas of Virginia, West Virginia. So yeah, we have rotation in this one as well. Another storm up here, getting close to West Virginia, producing maybe some hail. Nothing too crazy. So yeah, this is it right now. And overall, what you can see on this map, let's click back over here. Let it load in here. These little surface, these things at the surface, guys, I'm picking the worst colors over and over again. These things at the surface are pointing to where the wind is coming from. So you see how they're kind of going up like this? That means it's pulling up that warm, moist Gulf air all the way up around this surface low and really just kind of filling our area here, our risk area up with the majority of this warm air. So I mean, everything about this environment thus far is favorable. So we're going to leave this for a second and go back here. So now we're going to go here. So we're going to analyze the atmosphere a little bit because we need to know what environment these storms are going into. That is not what I meant to click on. So we can just keep this one. So we'll start with the upper level jet. This is the overall forcing mechanism for storms. You can see our storm activity right here. And I'm going to turn this off. So the boldest colors here, there's even a little 90 right there. That's 90 knots. The strongest flow aloft is actually to the south of where these storms are, which means that they're kind of being affected by, they're being affected by a little bit less wind speeds, but they're on the exit region. Obviously, this flows all over this area, and our risk area is kind of on the end, the exit region where these winds are kind of starting to slow down a little bit. And there's a whole lot of microphysics and fluid dynamics that goes into that, but pretty much it's a favorable area to be in for storms. Now, dropping down a little bit, this is the low-level jet. So our storms right now are ongoing. You can see them on the radar here. So you turn that off. You want these winds and this layer. This is about 3/4 of a mile above our heads. You want these winds oriented like this. They're kind of oriented like this right now. So you want them oriented more south to north, even maybe backed kind of to the northwest, and you want them stronger. So our risk area that we're watching the most right here is not being affected by this low-level jet as much. So we definitely need to watch as this increases. I mean, it's projected we will get over a 40 knot low level jet across this area over the next little bit of time. By a little bit, I mean like 4 to 6 hours, but still. We are expected to see a stronger low level jet enter this area. So we then drop that down and look at the instability again. There's just a broad area of uncapped atmosphere. This is not crazy. I mean, if we were seeing numbers like 2,000, 3,000 joules per kilogram, I would be really, really worried. But we're not. And one thing I will say is that this time of year, you don't need that kind of rocket fuel type instability. You really only need 500 to 1,000 joules per kilogram, and we have that kind of on the lower end. I think the maximum that we could see is 1,000 to 1,500 in this area. And this is projected to stay about the same over the next couple hours. So our ingredients definitely lining up here. And a way to summarize this is the supercell composite parameter, where you see the most, the highest values here. So we have 4, maybe 6 in some areas. That is where what am I trying to say here? The atmosphere is essentially the most favorable for all hazards. So it's the most supportive of severe weather. You can see it down here in areas of even Tennessee, Kentucky. It starts to drop off as you get up to the north. Now, over the next couple hours, this is expected to kind of get its act together. And we have it kind of increasing up in areas of Illinois, Indiana, which is where our risk area is. We can't forget that our risk area right here is not even really all that close to where these severe storms are right now. We don't have a whole lot going on up here. So let me see here. I'm going to mute this. So if we look at where Brandon is, where he's driving, he's actually remaining to drive west. This is interesting to me because he's going away from where the storms are. You might be thinking, well, that's ridiculous. And I think it's a little bit odd. However, at the same time, he might be trying to catch these storms right here. Why he would be doing that right now, I don't know. He is a professional though, so hard to tell. So let me see here. I'm gonna go over this in just a second here. So I'm gonna leave this frame up. So now I'm going to look back over here and kind of read your comments a little bit. So does this mean I can't have your number? I thought you already had my number. But I mean, I'm not going to give it out on stream, but that's interesting. But imagine picking a beta color. Yeah. Yeah, I can't. You guys, if you've been watching for like the past 5-10 minutes, you know for a fact I cannot pick the correct colors for this. It's kind of funny. I don't really know what's going on with me. So, yeah. Let's see here. Brandon Sanderson. You guys talking about? There's Brandon Kopic. That's if you're talking about Storm Chasers. I don't know who Brandon Sanderson is, but good for you, I guess. That's funny. So let's see. Current storms right here. Did they drop that severe warning? So let's see here. Let's go back a few frames. Yeah, so they've actually dropped the severe warning from, let's see. They've actually dropped the severe warning from this storm right here. Maybe for good reason. It's starting to fall apart a little bit. It might get its act together again in a minute. It's very possible. These storms, it's as favorable as the environment is. It does somewhat support them, these like pulse type storms, mainly because, and I'll explain this here, there is such a strong upper level jet across this area. It's so strong, possibly, that it actually could shred these storms apart. They kind of get started at the surface and then they poke up into the atmosphere, and I mean, it's possible that they're getting to a certain height and then they hit that mid-level jet and then just shred apart. So very possible. This storm up here, where is this at? Far northern areas of Kentucky right here. Also appears to be rotating, at least on a surface level here. Maybe a little bit. There's possibly a little bit of rotation in this area. Very broad and not too put together, but it might get its act together. So very possible we see that. And yeah, I mean, our overall risk area up here, um, we do have storms. I mean, for example, these storms here, just north of the Ohio River in areas of Illinois, Indiana, absolutely all have the potential to become very dangerous over the next couple of hours. Even the short term, the next like 30 minutes. So we'll watch them closely. One thing I'm going to do on the fly here as well is pull up. Let's see if I can find it. Yeah, it's an autocomplete. So I'm going to pull this up. This is more for my use than you guys, because I understand this stuff a little bit more. Let's see here. So yeah, I mean, what I'm looking at here is hodographs, the wind in the atmosphere plotted with height. These numbers are numbers of kilometers, so 1, 2, all the way to 6 kilometers. And the hodograph shape, the line this hodograph makes. So on here, it's kind of like that. That's roughly the shape of the storm. So that's why we see some of these storms kind of have that hook on them. They're kind of long, like they have a hook, but they kind of extend out further. That's partially due to the upper level winds being so strong. Let me see if I can do this here. I guess not. So if I put this in motion, yeah. So let's select like this frame. So yeah, these winds are pretty strong. I mean, they're out past 100 knots, about 8 kilometers or so. Like nothing crazy. But at the same time, this is enough to shred storms apart as they get higher in the atmosphere. And I think if we go back and do a little bit of analysis here, get rid of that. Goodness gracious. Let's try this one. So this was the storm that had that look to it. So we look right here, right about here, and we look at echo tops. Well, kind of like we were saying earlier, 28, 30,000 feet in this area. So 30,000 feet. Um, let me do this on the fly here. So it's 9 kilometers or so up in the atmosphere. So then if you take this right here, 9 kilometers, and you look here, 8, 9 kilometers is out near probably 120 knots or so. So very much enough to shred these storms apart. That could be a fail mode for this, is that these storms can't get tall enough and get their act together before they get shredded apart by the mid-level jet. I mean, I could see that being a reality here, but at the same time, um, I do want to reiterate that is that these storms, just because they form, doesn't mean that they're just going to instantly be horrifically strong. Let me get rid of the SPC outlook here. We don't need this. So if you look at these frames of satellite, I'll turn the radar on so you can see it. So get an idea of where these storms are rolling through, and then I'm gonna turn the radar off. Do you see how? Let's take this frame for example. I'll leave it in motion. You see how as these storms form and push their way up in the atmosphere, the winds go quickly downstream. So are the clouds, the anvil, the kind of dead cloud debris goes quickly downstream. And that leads me to believe that the mid-level jet is just so strong, it's shredding these storms apart. Now I can turn the jet stream on. So in the mid-levels, the 9 kilometers is getting up into what is considered the upper levels. But I mean, this right here is the mid-level jet overlaid. So let's take this right here. About 70, 75 knots in the mid-levels. That's great numbers of shear for severe weather. That's very supportive of severe weather. But at the same time, it might be so strong that it's shredding them apart. And if that's happening, it's going to take a lot more for these storms to really get ramped up, really get going in this area. So it's hard to tell. It's very hard to tell right now exactly what we're going to be seeing, but these storms are very active. There's a lot going on with them. I'm going to just click on this and just get an overall look. So, yeah, these really more than anything else right now, these are just hail producing storms that are being warned in these southern areas. However, let's put this in motion. I'm going to show this to you. These storms right here between Evansville and Princeton, Indiana, they're moving kind of more to the north. These storms down here south of Louisville over towards Lexington are almost kind of moving to the east. These are kind of moving to the north more because they are closer to and more in line with that low level jet that's pushing them off to the north. So these storms over here have more of a chance to be impacted by the low level jet, which means they're going to have more rotation potential, and they're going to still have a pretty similar thermodynamic environment. They're still going to have that instability. So yeah, that's just these storms back in this area are what I'm most concerned about. And I also want to note that that Brandon over here is he's actually heading north now. He just got off Interstate 50 in Indianapolis, or heading up towards not Indianapolis, Illinois. He's in Illinois, heading north. I don't know what he's on now. But he's headed up that way. It tells me he's starting to target this cluster of storms. So who knows? Exactly why he's doing that. I'm not sure. But we have a few other storm chasers that are doing this as well. So definitely need to watch. I'm not nearly as concerned about these storms down here when it comes to their overall damage potential. Yes, they can be dangerous. Yes, they could possibly put down a tornado. But at the same time, I'm more concerned about areas further to the west. The Storm Prediction Center is more concerned about areas to the west. And just overall, I think these storms down here in Kentucky have potential to do a lot, but I think the majority of their danger will be from hail, not as much from tornadoes. But I mean, if you put this in motion, like we had it a second ago, I don't know what that was. You can see how this extension of red right here, that was an issuance of a tornado watch in this area. So they extended the tornado watch over just a little bit. So that's I don't know. I honestly wouldn't necessarily have done this if this were me. I mean, I'm not an expert, I'm not a professional, but at the same time, these storms seem to be falling apart so quickly because they're being just shredded by the mid-level jet, and the low-level jet is not quite in place yet. That would lead me to believe that maybe uh, they're just they're just struggling a little bit more. That's not to say that these ones up here in Indianapolis, getting up towards Indianapolis with time, won't struggle too, but I just wonder. Central Indiana right now for a wind environment. Let's see. Let's click on one of these later frames. I mean, yeah, the wind environment across the board here is supportive. The real tornado potential won't come for another little bit of time. It really won't. So because of that, there's obviously a lot going on right now. There's a lot of little warnings and watches, this and that. But I might actually hop off for a little while, let things marinate a little bit, and then when things get more active, because I really do expect them to, I might hop back on. Don't know. One thing I don't want to do is live stream for no reason. That's a waste of my own time. So I might consider just hopping off for a little while. Not really sure yet. But I'm gonna go over here. Let's see. Look at the latest HRRR model, the full one that we have. Surprised that we do not have the 20Z run yet. So it's a little hard to tell exactly. It's very messy looking here, but again, the more widespread dangerous coverage doesn't happen until closer to like 8 tonight. So who knows? Hard to tell. Um, I might honestly wait just a little bit longer before I really get going into this. The latest run of the HRRR, though, it is somewhat concerning still. I'm going to see if it's run fully on another website. Let's see. Is this sector? We'll just use this one. 19Z. No. So, interesting. Let's keep this here. Just get rid of this. So, let's see here. Let's check for reports again. More hail reports have come in. 1-inch diameter hail. So yeah, these storms down here seem to just be more more hail producers in areas of Kentucky. So I'll let this reload and do its own thing. We never really did check for the 20Z update. I said that near the beginning of the video, and so let's see here. They've really not changed a whole lot with this. No changes to the ongoing forecast appear needed at this time. Yeah, dew points have had a tendency to mix to the upper 50s. So what that really means is that there's drier air aloft. That's how it typically works. And there must be, in the atmospheric boundary layer, the planetary boundary layer, just above the surface, there's turbulence, and that is bringing drier air down to the surface and bringing that moisture up and then drying it off. So it's kind of overall lowering the dew points. You need dew points probably up near 60 degrees to start off with. So what they're saying here is that they're mixing into the upper 50s across most of the area. I'm gonna do it like this. I'm gonna watch the radar across most of this area. So let's look here. 60 degrees, 63 degrees. So let's look across our risk area. Let's look at some observations. 59, yeah. 59, 58. So with northern extent, we definitely those dew points are definitely mixing a bit more. Down here to the south, maybe not so much. 63 degrees. Is this storm rotating again? No, this is the same one. Let me go to that. Well, let's go to the latest frame. This is I apologize. I don't know what I'm doing, guys. Yeah, we're still in the mid to upper 50s across most of the risk area. So take that. No, I'm just gonna do that and do this. So let's see. Convection has thus far struggled to mature and intensify as a result, and we've been seeing that areas of southern Illinois into southwestern Indiana should be favored for more robust storm initiation over the next few hours. So again, I might hop off and then go to do it later. Let's see. So yeah, there's all this discussion. I'm not going to read this. I don't feel like it. So one last look here. I've gotten a request to read the comments out loud. Don't know if that's a good idea, but I'm going to do it. Might as well. This is one last good look at what we're seeing right now. Just not super organized. A lot of kind of messy spottiness across this area, and we are seeing clearing though. So daytime heating is definitely doing its job. We're getting temperatures into the 50s, the 60s, even 70s in some locations. But we need to watch those dew points as they increase. So I'm going to put you guys on a satellite loop and turn this off. Across this area, I'm going to reload it and get rid of it. So when it comes to reading your comments out loud, let's look over here. There's way too many to just read out loud. I'm not gonna lie. Let's see. Where do I even start? That's the problem with this. There's literally so many comments in this area. It's kind of ridiculous. Um, you guys seem to be, um, you guys are like playing as different people. Um, you guys are using one of you guys must be using the same device, and you're different ones. Okay, well let's just go for it. Nah, never mind, bro. I'm not reading all this. This is crazy. If you have something you'd like to say specifically, um, then just just go for it. I'll read. How about this? If you guys want to say something, then put some comments, and I'll read the next like five. So just do it like that. Um, let's see here. And if you guys don't have anything else to say, then I'm just gonna hop off. It's now 3:50. We've been going for an hour and 6 minutes, so not too long. But um, if I'm gonna devote more time to this, I want to do it later, most likely. What is the weather like in Germany? Hmm. Let's do it like this. Should be able to do this. Just by the way, I did see this comment earlier, but the reason I didn't read it is because I thought it was ridiculous. Hard to tell where you're looking here. There's a lot going on. Let's change this over to forecast loop. So here, there's a very complex looking pattern over in this area right now. Some snow and rain over the next a little bit of time. Temperature wise, quite cold across a lot of areas. These are all in Celsius as well. That's why. Do we have either way? 0 Celsius is 32 Fahrenheit. It's pretty cold. Negative temperatures in areas. Yeah. Um, read it. No, I'm not gonna do that. There's too many of them. None of it makes any sense. What happens if when you put lime in the coconut? Like I said, literally not that long ago. I don't really know. I don't know what happens when you do that. Here's the snowfall over the next little bit of time. So, all right. I'm gonna do it like this. You guys are not letting up. You're gonna make me. Um, I'm just gonna go to the top and read the funniest ones, I guess. Um, I'll give you a cookie if you say hi, Pookie. Well, I'm not gonna see you in person, so I don't believe you. Um, there's the Germany comment again. Um, You're not reading all that? Yeah, I didn't want to either. I know what you're talking about. I didn't do that. Um, I'm not gonna play the Twisters movie on a live stream. You guys can watch that. Um, let's see. Yeah, I answered that question. Let's see. But I was mistaken. Let's see. Whole lot of stuff about Dolly Parton. Interesting. Um, because Dolly makes good cinnamon bread. Okay. You guys freaking weird. Hello there, Charles. Um, going to Dollywood. Yeah, you can call me a nerd as much as you'd like. That's why I'm live streaming. It's because I'm a nerd. Let's see here. Um, yeah, what is weather? We have a very beautiful definition. Not that far below. Um, weather refers to the state of the atmosphere, such as rain and sunshine, as defined by Luli herself. Let's see here. Talking about some sort of artist. Um, imagine flirting with the wrong girl. What are you talking about? That's crazy. Oh yeah, yeah. Imagine that's crazy. Um, you guys are, yeah. Let's see. Okay, I'll say it. Hi, Eden. I'll say it. I'll pay for the chicken fingers next time if you say hi. Um, all right. With that being said, it's now 3:56. So I'm gonna hop off. I will likely come back once this really gets going more. Let's look at this. Yeah, we gotta wait probably a couple more hours before anything really crazy gets going. So, um, okay. They were pretty good chicken tenders. Those chicken tenders are pretty good. Not all of them are that good. Some of them were pretty good. Um, she did. My mom did pay for those. So yeah. All right. I'm going to hop off. Feel free to come back on later. Um, so I'll see you guys and tune in then.